All right, this is the calculator part um, of the chapter 1 review. And we're starting off, remember, every final answer we do will round to 3 decimal places, the nearest thousandth. We're starting off with a linear regression problem. So, a pediatrician wanted to find a model that related a child's height, h, to their head circumference, c. She randomly selects 9 children from her practice, measures their height and head circumference, and obtains the data shown in the table below. Use the graphing calculator to find a linear model to fit the data. Use correct variables established in the problem. So use h and c instead of x and y. And actually, let's see. H of c. Do I really want this to be? Let me double check this. Seems like we would predict height based on head circumference, not the other way around. Yeah, okay, sorry. So I actually wanted to I need to switch this table. It's correct in the paragraph, but yeah, let's go ahead and switch this. So the height is the output and the head circumference is the input. I would not confuse you like that on the actual test. I've double checked that that's not the case. And the AP test, I don't think would be very sneaky like that either. It tends to be inputs are on the top and outputs are on the bottom. So I apologize for that. All right, so let's get this into Desmos. So to add a table to Desmos, you do plus table. And remember, we're putting head circumference first. So let me get this so I can see them all. There we go. So 16.4 is the first X value. I'm just typing in the numbers and hitting enter. 17.5, 17.3, 17.5, 17.5. I feel like I missed one. Let's see. 16.4, 16.9, another 16.9. Can we insert? No. Okay. 16.9. Oh, I guess if I would have, let's see. You're seeing me learn about Desmos in real time. Okay, let me just start that over. Okay, so 16.9, 16.9, 17.6, 17.3, 17.5, 17.3, 17.5, 17.5. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that matches up. Okay, now 25.25, 25.75, 25, 27.75, 26.5, 27, 26.75, 26.75, 27.5. Doing a quick scan of these to see if they seem correct. I do this on my graphing calculator too if I'm doing it that way. Remember, we can zoom fit. So here's that scattering of data. We want a linear model, so we can click this and have it choose linear regression. And I like to click this. If I'm probably going to plug a number into it, I like to have that here. Just kind of put parentheses around my X just in preparation for that. Okay, so I'm going to write this equation down. So use the graphing calculator to find a linear model for the data. So that was, remember, height was the output. So h of c is equal to 2.14974. Instead of x, I'm going to put c minus 10.527. Use the correct variables established and fill in the blanks with context. So h of c models what as a function of what? I've been saying like based on, so same thing. So its output is always being modeled based on the input, or it's a function of the input. Okay, so what is the output? The output is the height in inches, and the function is based on the head circumference which is also measured in inches. Interpret the slope found in part 1. So the slope was this number. So on average, remember this is kind of a script. On average, output increases by this much per input. So on average, the height increases because it's a positive slope by 2 point, you can round this, 150 inches per, this is weird, inches per inch. And I'm going to write inches per inch in head circumference. So for every extra inch you get on your head circumference, we are predicting that you will be 2.15 inches taller. Use the model from part A to predict the head circumference, to predict the height. Oh no, yeah. Okay, to predict the head circumference of a child who is 3 feet tall. So that's H, we're trying to figure out C. So set this equal to 3 feet. Now 3 feet is 36 inches. So we need to set our H of C equation equal to 36. When you are solving equations and you're really just going to solve by graphing, you're not really doing much in Desmos, you can just, it's good to at least write the equation and then say what C is equal to. I could solve this algebraically, but it's so much easier just to say, okay, here's the equation. Let's erase the X and put in a 36. And it tells me right here, 66.863. This has me wondering about my own head circumference. Like, that seems very big. Is this likely? Maybe the model is not accurate. That's fairly big, right? That's a huge head based on someone who is 3 feet tall. So that might be, maybe the model is inaccurate. I would not think that height, I can't imagine that your head circumference grows as quickly as your height. So there's got to be some sort of drop off. This would be a giant head, I think. Okay. Kinetic energy is directly proportional to the mass of an object and to the square of its velocity for all you physics people out there. So K equals 1/2 mv squared, where K is measured in joules, m is the mass of an object in kilograms, and v is measured in meters per second. Suppose an object has a mass of 3 kilograms and it's moving for 10 seconds. Then the object's kinetic energy could be modeled as this. So what was all this about? This is all extra fun background information. They love giving us more information than we actually need to do the problem on the AP test. So almost every AP test is sort of like a reading test in disguise. So here's the thing I care about. Mass is fixed. It's 3 kilograms. So they just put in a 3 for the m. Suppose the object's velocity is modeled as a function of time. So the velocity can be 4t minus 1 as long as t is between 0 and 10. Write a model for k of v of t with domain and interpret the meaning of the model in context. So k of v of t is really just k of 4t minus 1. And so you just plug that in for v. It's 3 over 2 times the quantity 4t minus 1 squared. And the domain for that has to match the t because t is the input here. So we still have to keep t between 0 and 10. If t is 0, by the way, velocity can be negative. It's just telling you which direction the object is moving in. So that's okay. Interpret the meaning in context. So remember, this models output based on input. So this models k. What was k again? K was the number of joules, so it models kinetic energy in joules. Based on, what's it based on? It's based on t. What is t? T is time in seconds, I believe. Based on time in seconds. Find the kinetic energy at 4. So I'm going to use Desmos to do that. I guess this one's not that difficult of a calculation, but I'm just going to say, okay, because I'm going to set this equal, plugging in 4 is easy. Solving and setting it equal to 1,000 is not as easy. So I like to do K of, remember, T. Don't do V of T. It'll get confused. So K of the input is equal to 3 over 2 times 4T minus 1. That quantity is squared. And again, if you want to look at this graph, you can say we're supposed to go from 0 to 10. Give me K of 0 and K of 10. And please zoom fit to wherever that graph is. There it is. Find the kinetic energy at 4. So just say, well, what is K of 4? 337.5. So K of V of 4 is what you really found. That's equal to, I already forget what it was, 337.5. And K is measured in joules. Find the time at which the kinetic energy is 1,000. So show what you're solving. You're setting this equation equal to 1,000. And it's not that these are difficult to solve algebraically. It's just that throughout the years, I've noticed that people make lots of little, just like silly solving mistakes when you could just graph this and solve. And solving by graphing is a skill that you need for AP Pre-Calc and for calculus as well. So all I'm going to do is type in y equals 1,000 and find the point of intersection. I don't want this other one because remember, our domain is only from -1. Or no, sorry, from 0 to 10. So we only want the positive value. So round that to 3 places. It's about 6.705. I'm just going to write T is about equal to 6.705. And that's measured in seconds. Sorry, my pen's starting to give out on me here. But yeah, so again, these are the 2 things that you'll need to be able to do for our test. You've got to be able to put in a table into Desmos and find the linear regression, interpret slope, plug a number into it, maybe set a number equal to it. And then same thing for this, write out a composition model, be able to plug a number into it, be able to find the intersection on a graph. And please come see me if you need help with this. It's just a matter of practice. Hopefully you've been doing it in your homework.